Hello community, so great that you are back. A lot of you ask me, hey, can you finally explain DSPy 3.0? What is it? Where's the magic? How is it connected to Lean 4? Hey, what is the difference? Explain it. Well, of course, let's start with DSPy 3.0. Now, it's almost 2 years since I did my first video, but let's say the core idea is the same. You're programming here and not prompting your LLM. So if you want, we can go now from prompt engineering to context engineering, if you prefer here the more marketing slang. So let's have a look. Context engineering with DSPy. You have more or less just two things that you do. You have DSPy programming. What does it mean? It simply means you write a high-level pipeline in Python using here specific modules in DSPy that are given to you. And then you have an optimizer. This is a compiler. That's all you do. It's an optimizer that runs on your high-level pipeline in Python. Full stop. Done. This is all there is to know about it. You see, it is easy. I told you. So if you're interested, of course, everything started here in October 2023 with Stanford University and a beautiful paper here, DSPy. And we are talking now here, yes, we have a GitHub. We are talking now about the very latest implementation. And just to give you a hint, already here in the title, they showed you what it is. It's a language model calls. So this thing calls LLMs. You know this. MCP protocol, we would say in 2025. Yeah? So it calls language model for help. It's so easy. The same time about here, this is already version 3 from April 2024, we have Google DeepMind. And Google DeepMind did a beautiful study on LLMs as optimizer itself. And they called this here optimization by prompting, prompting, optimization prompting. A simple and effective approach to leverage here our LLMs, your GPT-5, your Grok 4 as an optimizer, where the optimization task is now described, careful, in natural language, in English, in German, in French, in Italian, in Spanish, whatever you like. Great. It couldn't be easier. I told you. Now, there was then this beautiful idea. Let's take here this OPro, this prompting optimization for multiple modules that we can program. And I said, of course. So what we have a module level optimizer. Beautiful. So we have here a history of model level instruction and program scores that pairs now together and are given as an input to, GPT-4 Omni to generate now new prompt instruction for each module. And those are then evaluated here by your Python program. You just run it and you get a score from, 0 to 10, whatever you want. And this is added back with each module instruction to the module history. And then we just let it run here in a loop for multiple iterations. So we have a system that tries to self-optimize itself. You see, couldn't be easier. So the beginning was simply here bootstrap a random search operation. No? In bootstrap demonstration for each module, you have this simple process and then you just run it and you get results. No? One result maybe has a score of 32%. One has 16%, one has 54%. Beautiful. Now, the moment we entered different modules into this equation, it was so beautiful because OPro was there already invented by Google. So we just combine this with this, and you're not gonna believe what we get when we have this. This is now our DSPy optimizer. This is the magic of DSPy. I got a lot of questions. Hey, can you explain what the hell is DSPy? Why is it using here a teleprompter? Why is it using here compiler functions? Forget about all the technical terms. It is on the core, on a deep level core. It is a simple program. I will show you 2 examples. We do it together and you will laugh in 5 minutes how simple it is. Now this optimizer, that's a beautiful paper if you want to continue. This is here also by Stanford University and a partner UC Berkeley, MIPRO. What is it? Multi-prompt instruction. And you say, oh, great. So we move here from prompt optimization to context engineering, the instruction for a proposal optimizer. So you see, it's just optimizer here, different instructions that are related to a prompt. You do this every day if you put here an in-context learning prompt to your LLM. Nothing special, no magic. Yeah, here they show you 19%, and they officially say then 18% and then 13% for different things. So it helps, it improves your accuracy, and it depends on your domain, it depends on your complexity that you build in your Python program, it depends on the LLM you use. So in general, it improves against simply a human trying to find the best prompt. MIPRO normal optimizer using here a best-in-class open source LLM. But yeah, if you have the money, you go with the real expensive but excellent code optimizer or whatever you like. MIPRO, I told you, this is the most important and the most complex optimizer for DSPy. If you understand MIPRO, you understand everything, you understand the core. So, first step, and we do 2 complete examples, so this is just to warm you up. Step 1 is simply, we take some demonstration, we bootstrap them using here the same process like we used in Bootstrap random search. Then we have instruction, and we will have a grounding strategy I show you. And then we just don't have here a simple search. My goodness, I said this once in a conference. This is just a trial and error, and my goodness, I was corrected. No, this is a perfect optimization for a search process. So here we have Bayes optimization, then is used to find the best performing combination. Careful, we have 2 elements. We have the instruction and the demonstration candidates. This is all there is. This is the magic. So let's have a look at this. Yeah, of course, DSPy 3.00b2. This is what I'm using here. So beautiful, you know exactly GitHub. Great. So let's do the simplest hand-on experiment that you get a feeling for this. Let's say you create a program that accurately classifies your incoming emails into just 2 categories, technical support and billing inquiry. And you might say, hey, yeah, multi-agent, wait a minute, this is here DSPy. So what does DSPy do? We have to first understand here the core of DSPy. So we decide it shouldn't just classify directly, no? We say, hey, okay. So first step is you look at the email, you try to understand the email, and then you let AI summarize the content of the email, identify what is the core problem of the user, what does she want exactly, and then we classify here that summary and we say, okay, you belong to technical support or you belong to billing inquiry. So as you see, we have 2 steps. So what we do, we build a pipeline here in Python with 2 modules. Can we do this? Of course, it's easy. Look, we have here, signatures, beautiful. And then we have here, if we call this a ticket classifier, if you want, in our DSPy modules, we have here a summarization and we have here a classification. And that's it. This is our little, if you want, Python program where we have only signatures and modules that we define. And with this example, you say, hey, so easy. Technical support or billing inquiry, or you get an email. Yeah, input, output, input, output. You get the idea. What we do now is we take this program and we say to the machine, hey, optimize this. So we let this run now through MIPRO. MIPRO is simply the optimization engine of DSPy, one of the optimization engines. So what we need, of course, hey, any optimization problematic needs training data. You have to define, hey, this is my domain. I'm working in whatever, customer support, let's say. No? And then you provide 20 to 50 examples, not 1,000, not 10,000, just a very small set, 20 to 50 examples, where you say, this is what I want that a machine does. This is perfect. I have this email coming in. This is the destination. I have another user with another query, another problem. This is the correct destination. Support or billing. So you have to give your golden examples to the machine that it can learn, that it can bootstrap from those examples. Otherwise, where should the machine know? No? Yeah, it has some general parametric knowledge, but maybe this is not what you want. So you define your training data. How you do it? Well, guess what? You say, hey, email body, hey, I can't log into my account. I reset my password, but it's not working. So what is what you want? You say answer, technical support. If somebody comes with an email body, hello, I was charged twice for my last invoice. Can you please help? What is the answer that you want? Billing inquiry. So 20, 50 examples given the complexity of your task. If you have only 2 modules, easy. If you have 7 modules and a highly complex tree structure, yeah, 200, 400 examples. Show every possibility. You define how you want the behavior of AI. You have to do this. And you have only one other point, the metric. When it is it successful? So in our Python program, you have now a Python function to check if the final answer given by the AI is really correct, is really the answer that you have here defined. You can go with whatever metric you want. It must be the identical word, it must be the accuracy, it must be a percentage, it must be a numerical value, it must be whatever. Go anything from accuracy to F1 score, you can build your own metric for your specific case. And if we have this, our little Python program, we have defined here the training data set and we have defined a success metric. That's it. That's it. Now we send it off to MIPRO. Now the magic of DSPy happens. No? Step 1, bootstrap the demonstration. This optimizer now runs on your training data. It says, okay, this is what the user wants. No? Module 1, summarizer. Module 2, the classifier. Takes here the core issue or generates the core issue, user login problem, and then classifier, the user login problem, generates now categories, and you get the idea. Now, if it runs on this and it gets here the right thing, the right answer, and the metric says, yes, 100%, this is it, we have a successful trace. What is MIPRO doing with this demonstration? It saves it. So a safe demo for the summarizer might be email body, hi, I can't log in, core issue, user login problem. So now the system has defined for my training data with the intermediate step of identification. What is the core issue of this email? We have now, if you want a chain of thought in between, it's a user login problem, a classification, a classifier that then with the core issue, user login problem, we have an absolutely clear path forward technical support. So you see, great. And we do this and we run this and MIPRO generates with this process here a huge pool, depending on your training data, of high quality demonstration for both modules. Remember, we have the summarizer and the classifier. And you can build, 20 of them. And now if you want comes the creative step. And whatever we do in AI, when you see a creative step, guess what? We call an LLM API call. So now MIPRO as an optimizer tries to write a better instruction for each of your module. Optimize the prompt example that you have given. MIPRO itself is an optimizer, so it needs the help of a Titan AI, of a beautiful, big, highly intelligent AI, another LLM. Let's go with, if you like Grok 4, if you like, Sonnet 4, you get the idea. So, classifier. Current instruction, classify the core issue into technical support or billing inquiry. No? The core issue, you remember we had here, where is it? The core issue here, we identified here the core issue, the intermediary, the first step that we found. So, and MIPRO's Python code now writes a meta prompt to GPT-4 to ask for better ideas. MIPRO says, hello, little GPT-4, help. Can you please optimize this prompt? Thank you. So we have now a meta prompt. It says, you are an expert prompt engineer. You know this. Suggest a better instruction for the following task. Task, classify a user's core issue into technical support or billing inquiry. And then you provide examples, which has the first step, no? Must know what it's all about. Say, hey, these are my examples. And now generate a new improved instruction for my prompt. And now GPT-4 comes back, or the teacher LLM responds now. And what you want is a list of candidate instructions. So A, B, C, let's say, hey, you are a support ticket router. Read the core issue and determine if it's a technical problem or a billing problem. Respond with only technical support or billing inquiry. And you might say, where's the magic? This is the magic. It is just a rewriting of your prompt. You are just trying a different variety of optimization, of paraphrasing, of whatever you want. Look at the candidate options. Now with this new instruction, we have now a set of new instructions. So remember, new instructions and a pool of candidate options. Guess what? What is grounding? Yeah, this is important. No? The grounding is a very nice key innovation in DSPy, also in the older model. No? So you don't simply ask the LLM GPT-4 for the new instruction in a vacuum, because we are talking here about context engineering. No? So you ground this request with GPT-4 or 5 with a rich context you provide with your query. And the Python code constructs here a detailed meta prompt that includes additional context information for this prompt optimization. A summary of the dataset, a description of the program's logic, a successful bootstrap demonstration elements from step 1, a history of the previously tried instruction and their scores. It must learn, this was a good one, this was a bad one. And maybe a tip if you want to encourage a certain style of instruction. Hey, be creative, be simple. Just copy a persona. Whatever there is, you provide context so that the LLM, the GPT-4, 5, 6 can have better knowledge. And then the LLM uses this rich context that you provide to generate a list of n new diverse and contextually aware candidate instruction. Now for each module, the classifier and the summarizer. Context engineering is simply done. Beautiful. So what is the state in our optimizer? We have now, with MIPRO, a pool of candidate instruction and a pool of candidate demonstration for both of our modules. Now comes the, if you want, scientific step, bias, yes. This search combination. You want not just to know the complete result, but you say, hey, I have multiple modules. I want that you check for each module, each other combination of each other module. So let's do this. We have an optimizer, a very particular optimizer. I'm going to explain a little bit later on even more. We just want to find the best combination of all the module pools here. And we do this by running here a series of quick experiment or mini batches. So let's have a trial. 1, 2, 3, 4, 5. So here we have the summarizer instruction set and the classifier instruction set. And now we just combine them in different ways and we run it. And we get a real-time response back from the LLM. So you see here, not in a trial and error, but in a trial and a dedicated search error function, what is working. So you run this 12 times the LLM, 100 times the LLM. And you get, from your demo set, different scores. You say, hey, this is a good one. So, summarize instruction default, classify instruction default, you run it, 75%. Summarize instruction default, but now we take the classify instruction for candidate B, 91%. Huh? Now we switch around, we add now the candidate summarizer instruction of A and the classifier instruction of candidate B, 90%. Hey, but look, if we have here the summarizer default and the classifier instruction candidate B, then we get the best result. There's no logic or deeper reasoning behind it. It's just trying out all the possible combination here of the pool of your modules. It just runs through the combination. And it gives you, hey, this is the best result. It actually runs here your LLM and looks what is working, what is not working. No philosophy behind it. Yeah, a little bit deeper, it uses here a surrogate model, which uses here a very specific algorithm. I was not aware of this, a tree-structured Parson estimator, a TPE. What does parsen mean? This is the name of a statistical method used to create here the smooth heat map from a set of discrete data points. Wow, amazing. What is it for us? It's just an intelligent search algorithm that replaces here some random guessing with a data-driven strategy. It builds here, if you want, two separate probability models, one for the good outcomes and one for the bad outcomes, and then chooses its next experiment to maximize here the chances of finding even a better result in a combination of two separate probability models. Statistics, check. If you want more information about here this TPE surrogate model, this is for you. And you have in the paper much more information about it if you really want to have a deep dive. But for me, it's just a search model, an intelligent search model. And now what we get, after all of this, what is the result that we get? This is the prompt, the finally compiled prompt here for the classifier model. Now we have it. This is it, the perfect prompt. Analyze the following user problem summary. If it relates to payment, invoices, or charges, classified as a billing inquiry, otherwise classified as a technical support. And you might say, this is it? Yes, this is it. Plus, you have a format. Core issue, yes, yes, yes. So this is it. Now, this is a simple example. Imagine you have a real complex problem with a multi-step argumentation, reasoning, multi-agent. I'll show you with React module how you can build this. It is trying out every possible combination, and it gives you here an intelligent search algorithm back. It tells you, hey, I tried everything. This is the best thing that works for your particular problem. So there you have it. Complete, highly effective prompt generated entirely by the MIPRO optimizer. This is the result of an optimizer. This is exactly step by step what an optimizer does. You provide the logic, your modules, and the final answer for the test dataset. And then you just have here an optimization based on natural language. You might say, but this is too easy. Okay, no problem. Let's say we need now a program that not only classifies the incoming emails from your customer, but does so with more nuance, and prepares here even a ticket for an agent. 3 categories. Technical support, billing inquiry, feature request. A user is suggesting here a new capability or an improvement. Yeah, let's respond here to some new ideas by our clients. You want a priority assignment. Hey, this has a priority high, medium, low. Okay, great. Then you want to have clear JSON output. Beautiful. Now, this is all you need. You have summarize, classify, assign priority. Then you have here simply as modules here your summarization, your classification, and you assign a priority. And then you run this you compile this with the optimizer. So here you have a perfect multi-stage program. And now MIPRO is just trying out and finding here the best combination in an intelligent search. So MIPRO's Bayesian optimizer now explores here the landscape. It is not a random search. Never say that it's a random search. It's a guided discovery process here in DSPy. And here you have trial 1 to 5, and then we have trial 6, the breakthrough, and then we have an optimization, 7 to 20, we have a fine-tuning. Yeah, you just have to find solution. You can generate data set and say, hey, I want here, if you just have these few short examples in your prompt, it's in-context learning. But maybe you say, hey, I want to fine-tune really this. Maybe you have some module where you say, I want to have a LoRa adapter trained here. And then I want to see if a LoRa adapter is better than an in-context learning prompt. So you can build your models and your optimizer, you build your metric, and you can let the system run and experiment, and it will find here, after hundreds of runs of the LLM, a better solution. This is the magic. Yeah. This is here then, if you want to, for the more complex thing, this is then the prompt that you get here back from the LLM. You're a JSON formatting agent. Your sole purpose is to return a valid JSON object. The object must contain the key category with its value, a key priority, and a value of high, medium, and low. And you give here in-context learning. examples, few short examples, and you say, this is what you follow. This is the template. This is it. So if you go with DSPy, this MIPRO moves now beyond the simple search. Beautiful. It's a diagnostic and problem-solving engine. Beautiful. It uses data to find points of failure. Uses here a teacher LLM. This is here where you need the Titan from my last video. Here you need really the best LLM you can find here. Yes, you could go with an open source that you have it locally, but if you need a high quality, maybe think about that you go here and maybe even pay for those LLMs. It will generate targeted solution and then scientifically validate the solution to find here the final program that is far more robust and reliable than what a human prompt engineering could ever create through manual trial and error. Because now we have an automatic trial and search engine for the minimum error. MIPRO is just the most complex thing. There are other optimizers and algorithms. Few-shot or coordinate prompt optimization. This is all simpler. You just can have a look at it. DSPy is in a beautiful in-between of fine-tuning and manual prompting and in-context learning. Let's have a look at this. So first line is manual prompting. Second line is DSPy, and then we have fine-tuning. So you see, with manual prompting, what changes here is simply the prompt, no? The text of the prompt string itself. No? With DSPy, you have context engineering. No? The text of the prompt is now modified. You get new instruction, no? And few short examples. Just do this here with a JSON format in the output. And few short examples that are really specific to your task. No? Or you say with fine-tuning, I really want that the model learns this and really modifies here its weight so that it's really a permanent experience that the model learned. You modify the weights in the language model itself if you do a fine-tuning. Yeah? Cost and speed for the manual prompting by the human, fast to iterate, brittle and labor-intensive to get it right. Even if you're an expert, you have to try it out. Simple. Or you have the experience, the knowledge. No? DSPy optimization, it's a low cost. I don't know if you have a few hundred LLM calls, only if you have open source. No? If you go with the real proprietary like O3 Pro, it can become expensive real fast. So it's fast, yeah, but machine optimized. No? And you just need here a small labeled data set, depending on the complexity of your task, between 110 or 200 examples where you define this is what I want the machine does. Yeah, and for fine-tuning, you need thousands of examples. Now, it's really much more detailed. We have beautiful documentation, Stanford NLP DSPy version 3. Here I showed you here all the optimizer you see. This is the optimizers you have currently access to, and we were talking about MIPRO version 2. Yes, of course, you have all the code. Just go to Cursor, it knows everything about it. Cursor writes you the program within seconds. If you want to go here building tool using agent, yeah, you have, of course, from the module here, React. You can use here React to build multiple agents. They have all the code also here in the manuals for you. Beautiful. If you are interested where this came from, this is now, who had this idea? And the idea was, and now you are laughing, in January 2023, you know where does it come from? It comes from RAG. Because if you look at this very first publication, no? It was not DSPy, it was DSP. And what they had originally was Demonstrate, Search, Predict, DSP, a framework that relies on parsing natural language text, your prompt, in sophisticated pipelines between the language model and a retrieval model from your RAG system, or the retrieve, augment, and generate. So for the retrieval model, they wanted here, when you were looking for external data, to optimize the prompt of the retrieval model. So if you want, the very beginning of 2023, DSPy was just an optimizer for the prompt optimization of the retrieval model, and it just developed here in the next 2 to 3 years. How funny is this? Okay. The complexity of the task they found here at the old times at Stanford demands much more sophisticated search strategy for the RAG system that empowered here the retrieval model here of RAG to find here the relevant passages. This was January 2023. And they already suspected those examples are likely required now, multi-hop reasoning in particular. And they ask, can we automate this? Can we have a machine intelligence that simply runs through all the combination if I give you a particular starter set, a training data set? So funny if you look at this, and it is beautiful. Read the papers here by Stanford. They're exceptionally clearly structured. They explain every reference, historical reference, the development phase, really also the mathematics here of their modules. Real nice. But there's no magic. Sorry. Talking about magic. Lean 4. I got a question. Is Lean 4 in DSPy 3? The answer is no. Lean 4 is something completely different, but really similar and maybe the next step after DSPy. You know Prolog. If you are talking about mathematics and logic and causal reasoning, Lean 4 is really something in its own because it is an independent programming language. And it is a programming language system, a complete ecosystem. It has unique syntax, unique compiler, real ecosystem here with 4, you guessed it. And there's only one reason for Lean 4. It's a functional programming for mathematical proofs. Not for guessing, not for autoregressive next token prediction. No, for the absolute real mathematical proofs. So it has a very small but real powerful set of logical rules baked into the kernel of Lean 4. Its core logic, if you're a little bit into this, it's called the calculus of inductive construction, CIC. And you can think of this as the absolute, unquestionable foundation of the system. The axioms or the laws of logic, not really physics, sorry, this is standard. The laws of logic here, the mathematical implementations are just great. So if you have here DSPy, just to show you what we have. We have a feature DSPy with a TPA optimizer. The primary goal is an optimization to find the empirical best performing solution from a vast, uncertain space. The object is here a language model program, a Python object. The paradigm is simply probabilistic and empirical. We are running all the experiments. We observe the outcomes. And the truth is a labeled data set and a metric that I as a user have to provide. I tell you this is the truth that I want, and this is the metric that evaluates the truth. The process here is a guided intelligent search optimization. The output is just a highly optimized prompt, a string of natural language text. Guarantees that this is the real optimized solution? None. You're working in probability. This is guarantee, forget it. Maybe you're lucky this day. Maybe you're not. Application, everything in AI, RAG, agent, classifier, whatever you have. What is Lean 4? Lean 4 is the primary goal is not optimization but verification to produce a proof of a statement's absolute correctness. The object is not an LLM, it's a mathematical theorem. Paradigm is not probabilistic or empirical. Hey, I can try it out. No, it is deterministic and deductive from logic, mathematics only. The source of truth is not my metric, predefined logical axioms in mathematics and rules of logic itself that were developed in the last 500 years. The process is not a guided search, but an absolute logical proof construction by a step-by-step logical argument implementation. The output is not a single human-readable optimized prompt in the English language, but it's a formal proof term, a data structure representing here the logical argument in a way that maybe a normal human being can't even read this particular form. Guarantees absolute certainty. This is mathematics. This is not language. If a proof is verified by Lean 4, the theorem is mathematically guaranteed to be true. Application, formalizing mathematics, verifying software, verifying hardware correctness, formal logic, and now reasoning that is happening in LLMs. And you might say, oh, wow. So you're going to tell me that this is the next step? Because all our reasoning, even in Grok 4 and GPT-5, that hopefully will come out this summer, now we use not a tool like Prolog, but we go the very next step, and we go here with a tool like Lean4 to build an abstract mathematical reasoning construct that we can verify that the reasoning plan, like I showed you in my last video, the plan how to solve a given human query, the plan to execute to find absolutely guaranteed the right solution. Lean4 might be here the component that we are missing here in AI, in our large language model. Well, this is the big bet. I have companies, I see now startups financed by hundreds of millions of dollars that say, yes, we implement Lean4 for this. So, if you're looking for the next possible wave and the next theoretical, technical, mathematical development step of AI models, it is not only the models, but it is also what intelligent tools they will use. Like in my last video, you steal the planning document from a Titan AI. Maybe they don't have to do this, the little small language model in the future, because they have access to a Lean4 tool, and they have here a transcription engine that transfers the complexity of the human problem into a mathematical context. It is solved with Lean4 on a mathematical level, and then you can be sure that the AI output of your AI is really correct. This is the dream that we have currently in July 2025. And hundreds of millions of dollars are going into startups right now as I speak. DSPy seeks the highest score on a metric I defined. Lean seeks a logical truth. DSPy produces a highly tuned probabilistic artifact. Probabilistic. A prompt. Lean produces a provable, correct, deterministic artifact. A proof. The way forward to solve something. Have a look at this. This is the homepage. A beautiful, complete new language. Lean is a tier improver and a programming language by itself that enables correct, maintainable, and formally verified code for, let's say, a complex reasoning problem, a multi-step reasoning by an AI, a financial reasoning, a physical, a medical reasoning. You can use this prompt. The kernel is already beautiful. I think now is only how you optimize this with an AI, LLM, for example. So, I hope you enjoyed it. This was the summary. What the hell is the magic here in DSPy? I hope I explained it. I hope I've given you an idea, a feeling that you get interested in Lean4 maybe, and I've given you an outlook what you can expect here in the next month or years in the development of the next generation AI systems. I hope you enjoyed it. I see you in my next video.